Hello and welcome to my science tutorials. In today's video, I want to look at how to calculate the distance between 2 points in coordinate geometry. So without further ado, let's begin. So assuming we have a point A with the coordinate x1, y1 and another point B with the coordinate x2, y2. We got these coordinates by extending these lines. So let me quickly show you guys that. So if we extend the line over here, we'll get an x value over here. If we extend this also to the bottom, we get an x value over here. So the initial x value over here is what we are saying is x1, then the final x value is what we are saying is x2 over here. And then if we extend this line as well, we get the initial y value of this line, so that is y1. And then if we extend the one at the top over here, we can get a point over here, so we have y2. Now for us to be able to calculate the length or the distance between the point A and B, we need to know the distance between this point. Okay, so we extend these lines to come and join each other over here. So the distance on the x-axis, we need to know that. Then we know the distance on the y-axis as well. Then we use the Pythagoras theorem to find the distance from the point A and B. So let's look at how we do that. The distance from the point x1 to x2 over here will be the difference between the higher value of x, which is x2 over here, minus the lower value of x. So the distance over here from x1 to x2 will be x2 minus x1. So the vertical distance over here will be y2 minus y1. So we need to subtract this from this to get a distance from the top to the bottom over here. Now what happens if we want to find the distance of AB? So AB, the length or the distance of AB, we use Pythagoras theorem. So according to the Pythagoras theorem, the hypotenuse square, which is the length AB, so we have the length AB squared, would be equal to the length of, let's say this is C, so it will be equal to the sum of the length AC and BC squared respectively. So we'll have AC squared plus BC squared respectively. So this means the length AB squared will be equal to the length of AC, as I showed earlier on, is x2 minus x1 squared, plus for B and C it will be y2 minus y1 all squared. So now to leave the length of AB stand alone, we have length of AB, then we take the root of what we have on the right hand side. So we have x squared minus x1 squared plus y2 minus y1 squared. So this becomes the formula for calculating the length or the distance between 2 points. Now let's go ahead and have a look at some examples to further appreciate what we are talking about. So we have the point A and B are points 2,5 and 6,3 respectively. We are to find the gradient of the line AB, the gradient of the line perpendicular to AB, and then the length of AB. Okay, so let's write down our solution. So we have the point A with the coordinates 2 and 5, and then the point B with the coordinates 6 and 3. So this is my first x value, my first y value, so x1 y1. This is x2 y2. So now that I have this, I can go ahead and easily find my gradient. My gradient, or the slope of AB, represented by m, will be equal to the change in the y-axis to the change in the x-axis. So this is equal to my y2 is 3 minus my y1 is 5, all on my x2 is 6 minus x1, which is 2. So this gives me 3 minus 5 will give me a negative 2, and then 6 minus 2 will give me 4. So this is equal to negative 1 on 2 as my gradient for the line AB. Now, the gradient of the line perpendicular to AB. So now we said for perpendicular lines, if you multiply their gradient, you should get negative 1. So assuming the gradient over here is m1, if I multiply m1 by the gradient m2, which is the line perpendicular to the line AB, I should get the result to be negative 1. So if that holds true, then it means that m1, m2 is equal to negative 1, and therefore negative 1 on 2 multiplied by m2 should be equal to negative 1. So I have a fraction here, I need to get rid of it. So I multiply both sides by 2. So I have 2 multiplied by negative 1 on 2 m2 is equal to negative 1 multiplied by 2. This will cancel this. I have negative m2 is equal to negative 2. I divide both sides by negative and I have my m2 to be equal to 2. So therefore, it means the gradient of my line perpendicular to AB is 2. Alright, so let's go ahead and calculate the length AB. We said to calculate the length of 2 points, say AB, that will be equal to the root of s2 minus x1 squared plus y2 minus y1 squared. So the length of AB is equal to the root of my x2 is 6 minus x1, which is 2 squared, plus my y2, which is 3 minus y1, which is 5 squared. The length of AB will be equal to 6 minus 2 will give me 4 squared, plus 3 minus 5 will give me a negative 2. So I have negative 2 squared. So the length AB is equal to the root of 4 squared is 16 plus 2 squared is negative 2 squared is 4, and this is equal to the root 20. So therefore, the length of the point AB is root 20. And because we don't know the unit in which the axes were labeled, we can just say root 20 units. So if it is in meters, it is root 20 meters. If it is in centimeters, it's root 20 centimeters. Since we don't know the unit in which they are measuring the length of this particular point A and B, so we just add units attached to it. Alright, so let's go ahead and look at another example. So for the points P into bracket X, Y, and Q, 3x, 5y, we are to find in terms of x and y, I, the gradient of the line PQ, and then II, the length of the line P and Q. So let's go ahead and look at the solution for this problem. So we have the point P, which has x and y, and then we have our second point Q, 3x, 5y. We are to find in terms of x and y the gradient PQ and then the length PQ. Okay, so as usual, I will always write my x1, y1, x2, y2 over here for ease of calculation. Then I can go ahead and say I, the gradient of the line PQ, which is m of PQ, will be equal to y2 minus y1 on x2 minus x1. So this is equal to my y2 is 5y minus my y1 is y, my s2 is 3x minus my x1 is just x. So I have over here 5y minus y will give me 4y on 3x minus x will give me 2x. So this is equal to 2 will go here, 1 go here, 2. So our final answer is 2y on x as the gradient of the points P and Q. So let's look at II, the length PQ. So the length PQ will be equal to the root of x2 minus x1 squared plus y2 minus y1 squared. So this is equal to the root of x2 minus x1, let me just pick it over here, will be equal to 3x minus x squared plus my y2 minus y1 is what I have at the top over here, so I have 5y minus y squared. So from here, 3x minus x is the 2x I had over here, so I have 2x squared plus I have 4y over here squared. So this is equal to the root of 2s squared will give me 4s squared plus 4y squared will give me 16y squared. So my final answer, which is the length of PQ, will be equal to the root of 4s squared plus 16y squared unit. Like I said, since we are calculating the length of the line PQ, the length is always measured in a certain unit, whether it is in meters, centimeters, kilometers, we don't know. So we add the unit to let the teacher knows that we are still thinking about the unit that the length is being measured in. So thank you so much for watching. This is how we calculate the length or the distance of 2 points when we are given in a question. So thank you once again for watching, and I'll see you in the next video. Bye bye.